Hi, now I want to discuss what is the effect of overfitting. Okay, so decision trees are very prone to overfitting. Now why is that? Now just see, if we keep building the tree bigger and bigger, okay, as we have seen, our accuracy keeps increasing. Okay, so accuracy might increase or it might stay constant. Okay, generally it keeps increasing. So as we keep building the tree, that is, if a tree starts to grow in size, if the tree starts becoming bigger, we will be basically prone to overfitting. Okay, what I mean to say is, if we are, let's say, have sufficient number of features, okay, let's say we have sufficient number of features will enable me keep on splitting on those features. So I can say, if I have a bigger tree, okay, so if I have a bigger tree, I will have high training accuracy. Okay, we will have high training accuracy, which means that I will be overfitting as I keep building the tree. Okay, I will be overfitting as I keep building the tree. So if my tree grows in size, it will, the bigger the tree, more the overfitting. So what are the things we can do to avoid a tree being so big? Okay, so what we can do to avoid overfitting, we have three options with us. Generally the three options that we consider. So the first option is you can just limit the length of the tree, or I can say limit the depth of the tree. So max depth, that just give your tree a max depth that you should not be bigger than size 3, okay, that you should not be bigger than depth of 3. This is the maximum you can go. Okay, so this is what we can define, that you can have a maximum depth of 3 or 4 or 5, whatever we can give. In this way we can basically limit our tree size. Second, what we can do is no accuracy change. Okay, no accuracy change. And third is pruning. Okay, so now let's discuss one by one. So max depth, as I already said, we will be limiting the depth to let's say 3 or 4 or 5 or 6, whatever we want. But the problem with this is that we won't actually know when the accuracy starts to shoot up. Okay, let's say accuracy in the beginning was just increasing by from 0.5 to 0.55 to 0.66, and later on, after depth of 6 or 7, it suddenly jumps to 0.7 to 0.9. Okay, so we don't know about that. So we cannot just set the max depth because we don't know when it's just going to shoot up. So this is the problem with max depth, that in some of the cases it just might not work. Okay. Then there is no accuracy change. What this method says is that keep building the tree, when the accuracy stops increasing, just stop over there. So what they mean is basically that, let's say you start with an accuracy of 0.5, okay, you get an accuracy of 0.7, then you get a 0.8, and again here it comes out to be, let's say, 0.801, let's say. Okay, so what I can say over here is that accuracy has almost stopped changing. So we can just stop over here because accuracy is not changing anymore. So there is no point of basically going further deep and making a tree bigger, which will basically in turn do overfitting. So we can stop over here. But again, there is a problem with this. There is a problem with this. To understand the problem over here, just let's take an example. I am sure you know what XOR is. If not, let me just make the table for XOR. If I have x1 and x2, here I have y. Basically, if I have 0, 0, then answer is 0, 1, 1, answer is 0 again, 0, 1, answer is 1, and 1, 0, answer is 1. That if both of them are different, then answer is 1. If both of them are same, then answer is 0. Okay, I think you already know this, what XOR is. So if I try to make a decision tree for XOR, it might look something like this. Okay, so I'll be writing 1 as yes and 0 as no. So in the beginning I have 4 data points. Out of which 2 are yeses and 2 are no's. Okay, so now I decide that I want to split it on x1. If x1 is equal to 0 and x1 is equal to 1. So if I have x1 is equal to 0, that is this one, I have 1 no and 1 yes. Okay, so I have 2 data points over here, which is 1 yes and 1 no. And over here again I have 2 data points, 1 yes and 1 no. Okay. Now further I will be splitting on x2 okay, x2 I will be splitting on x2, 0 and 1. In this case my output is going to be, I mean there is only going to be one point which is going to be 1 no. Similarly, here I will have 1 point, 1 yes, okay. Here I will be having a for 0 and 1 point which is 1 yes, and here I will be having 1 point which is going to be 1 no. So basically at this level my accuracy is 0.5, okay. So my accuracy is 0.5. At this level again my accuracy will be 0.5 because one error from here, one error from here and one error from here. So accuracy will be 0.5 again. Here my accuracy is going to be 1, okay. Here my accuracy is going to be 1. Now just see this problem. If I used my accuracy change method, what I would have done is after getting 0.5 over here and 0.5 over here, I would have said that accuracy is not changing. So let's just stop over here, okay. So let's just not make any further splits because accuracy is not changing. So I would have just not made this below portion. I would have just not made this below portion, which would have in future helped me from 0.5 to straightway 1, okay, which would have made my accuracy 100%. So this is the problem, that it might happen that in 2 steps there is no change in accuracy, but after that there is a sudden jump in accuracy. So this is a problem that we don't know when accuracy might jump later on, right. So this is the problem with using this second method. Now we have a third very interesting method, that is known as pruning, okay. We have a very interesting method that is known as pruning. We have already discussed accuracy change and we have already discussed max depth. Pruning we are going to discuss in the next session, okay. So thank you.